decreasing the value of T2, that is nothing but the highest temperature at which heat is to be rejected. So these are the two methods, or these are the two options by which I can increase the value of COP. So after this, that means these are the two. By decreasing the higher temperature or by increasing the lower temperature, I can increase the COP of a reverse Carnot cycle. Then after that, we have seen the comparison between COP of same refrigerator which is used in the winter and COP of the same refrigerator which can be used in the summer. So we are knowing that as temperature or surrounding temperature in the winter is less than surrounding temperature in the summer. That's why COP in the winter is greater than COP in the summer. And after that, we have taken the another two examples. Those are nothing but related to the refrigerator, which is used for making ice at 0 degree centigrade. And second one is nothing but the air conditioner, which is used for obtaining the air at 20 degree centigrade. So we will get the higher value of COP in case of air conditioning plant at 20 degree centigrade as compared to refrigerator, which is used for obtaining the ice at 0 degree centigrade. So up to here, we have completed in the last lecture. Now we have to solve the problems based on reverse Carnot cycle. So shall we start the problems? Yes or no? Can anybody tell? Yes or no? आहे का सगळे? So before starting the problem, we will revise the formulas which we are going to use while solving the problem. So first formula we are going to use, that means as you are knowing that related to the reverse Carnot cycle. The COP can be found out by using two ways. First way is in terms of temperature, second way is in terms of heat. So write on your notebook, formulas used for reverse Carnot cycle. Formulas used for reverse Carnot cycle. So first formula we are going to use, that is nothing but COP of refrigerator is equal to what will be the formula? What will be the formula? Hello. Shubham Raut, what is the formula for COP of refrigerator working on reverse Carnot cycle? Bhushan Thakre.
Sir, T1 upon T2 minus T1.
Okay, right. COP of refrigerator is equal to T1 divided by T2 minus T1. So you are knowing the notation. T1 is nothing but lowest temperature, T2 is nothing but highest temperature. So this is the formula of COP in terms of temperature. In terms of heat, if you want to write down the formula of COP of refrigerator working on reverse Carnot cycle, what will be the formula in terms of heat? Tuzapurkar?
Sir, please repeat the question.
So Bhushan has told us formula for COP in terms of temperature. COP of refrigerator is given by equation T1 divided by T2 minus T1. So if I want to write down the formula in terms of heat, what will be the formula?
Heat absorbed upon heat rejected minus heat absorbed.
Okay. So
QA upon QR minus QA.
Okay, QA upon QR minus QA. So in general, we are writing QA as a Q1 and QR as a Q2 minus Q1. So you can write as a QA divided by QR minus QA or Q1 divided by Q2 minus Q1. So write down the another formula in terms of heat, that is nothing but QA divided by QR minus QA. QA divided by QR minus QA. So that QR minus QA is also called as a QR minus QA is also called as a Onkar Gund.
Yes, sir.
QR minus QA is also called as a
Q2 minus Q1, sir.
okay. That is also called as a work done on a system. That is nothing
Work
but
done on. Yes, sir.
okay, that is nothing but WD. And one more formula you have to write down. That is nothing but COP of heat pump is equal to COP of heat pump is equal to COP of refrigerator plus 1. COP of heat pump is equal to refrigerator plus 1. Have you written? Whether you have written these three formulas? Yes or no? अरे बोलो जाओ काहीतरी. Okay. Now after refrigerator, we have to write down the formula. Same formula is for the heat pump. So COP of heat pump is equal to, in terms of temperature, in terms of heat. Who will tell me? Rohan Kale. Rohan Kale. Pratikesh Kumar. COP of heat pump. Rishikesh Gugwe.
So T2 divided by T2 minus T1.
Okay. COP of heat pump is nothing but T2 divided by T2 minus T1. So this is in terms of temperature. So all of you write down COP of heat pump is equal to T2 divided by T2 minus T1. And in terms of heat, will tell me? In terms of heat. What is the formula of COP of heat pump in terms of heat?
QR upon QR minus QA.
Okay, QR upon QR minus QA. That is nothing but heat rejected divided by heat rejected minus heat absorbed. So by using these many formulas, we have to solve the problems based on reverse Carnot cycle. Have you written all those formulas? Yes or no?
Yes, sir.
Shall we start the problem? Shall we start?
Yes, yes.
Okay. So first problem. Shubham Kakade, read the problem. Kakade. Is Shubham Kakade present?
Hello,
Can you
hello,
read the problem? Can you read the problem?
hello.
Can you read the problem? Shubham. Hello? Kodak. Vasudev Kodak.
Yes, sir.
Can you read the problem?
Yes, sir.
Loudly.
A machine working on a Carnot cycle operates between 305 Kelvin and 260 Kelvin. Determine the COP when it's operated as a refrigerating machine, a heat pump, and a heat engine.
Okay. So there is a machine which is working on a Carnot cycle. So here, instead of using the reverse Carnot word, they will use the Carnot cycle only, because whenever you are applying the Carnot cycle in terms of refrigerator heat pump, that will become as a reverse Carnot cycle. And whenever you are applying the Carnot cycle in terms of heat engine, that will become as a only Carnot cycle. So don't confuse that here afterwards, whenever Carnot cycle word will be applicable or Carnot cycle word will be used along with refrigerating machine or heat pump, then you have to consider that Carnot cycle is nothing but a reverse Carnot cycle. So there is one machine which is working on a reverse Carnot cycle or Carnot cycle. That machine is operating between the temperature range of 305 Kelvin and 260 Kelvin. So we have to find out the COP. We have to find out the COP when that machine is acting as a refrigerating machine, when that machine is acting as a heat pump, and when that machine is acting as a heat engine. So first of all, we'll write down the given data. So what is the given data in this case? What is the given data? अरे बाबा ना काहीतरी बोला.
T1 and T2.
Okay, so they have given the two temperature. First one is nothing but 305 Kelvin. Second one is nothing but 260 Kelvin. So as they have provided the two temperature, so out of that two temperature, whatever lower value of temperature will be there, that will be considered as a T1. Whatever higher value of temperature will be there, that will be always considered as a T2. So here value of T1 will be equal to 260 Kelvin, that will be considered as a cold body temperature. And value of T2 is nothing but higher temperature, that is nothing but 305 Kelvin, that is nothing but hot body temperature. फक्त एवढ्या दोनच गोष्टी दिलेल्या आहेत आणि ह्या दोन गोष्टीवरून आपल्याला काय फाइंड आउट करायचं आहे? सीओपी ऑफ रेफ्रिजरेटिंग, सीओपी ऑफ हीट इंजिन. आता कोण सांगेल सीओपी ऑफ रेफ्रिजरेटिंग मशीन कसं कॅल्क्युलेट करायचं? Will tell me how to calculate the value of COP of refrigerating machine.
T1 upon T2 minus T1.
Okay, so we are knowing the formula in terms of temperature, that is nothing but COP of refrigerating machine is given by equation T1 divided by T2 minus T1. So you are having the value of T1, you are having the value of T2. So put the value of T1, put the value of T2. Value of T1 is nothing but 260 Kelvin, value of T2 is nothing but 305 Kelvin. So you will automatically get the value of COP of refrigerating machine, that is nothing but 5.78. So that is the value of COP of refrigerating machine. Second thing, we have to find out the value of COP of heat pump. We have to find out the value of COP of heat pump. COP of heat pump is also called as a, that is also called as the energy performance ratio. So how to calculate the value of COP of heat pump? Can anybody tell me how to calculate?
+1.
Plus 1. COP of refrigerator plus 1. That is the one way, or another way you can use the formula. So COP of heat pump is nothing but COP of refrigerator plus 1. So 5.78 plus 1, that is nothing but 6.78. That is the answer. Or you can use the another method, that is nothing but COP of heat pump is given by equation, another formula in terms of temperature, T2 divided by T2 minus T1. So put the value of T2, put the value of T1, you will get that answer as a 6.78. Are you getting? Yes or no? Are you getting?
Yes.
Okay. Now third one, we have to find out the COP of heat engine. So whenever heat engine word will come, so COP of heat engine means indirectly they have asked us to find out the efficiency of heat engine. Whenever COP of heat engine word will be there, so indirectly they have asked us to find out the efficiency of heat engine. Now who will tell me the formula for finding out the efficiency of heat engine? Heat engine ची efficiency कशी माहिती आपल्याला?
1 upon COP.
1 upon
COP.
COP of what? So you should have the clear understanding related to that schematic diagram. So whatever I have shown you, that schematic diagram. Yeah.
Sir, T2 minus T1 upon T2.
So efficiency of heat engine is given expression in terms of heat, that is nothing but Q2 minus Q1 divided by Q2, or in terms of temperature, that will be T2 minus T1 divided by T2, because output is nothing but T2 minus T1, input is nothing but T2. So we have to use the formula as T2 minus T1 divided by T2, efficiency of heat engine. If you want to write down the formula for efficiency of heat engine in terms of temperature, you can note down. Efficiency of heat engine is nothing but T2 minus T1 divided by T2. Okay, so efficiency of heat engine, that is nothing but T2 minus T1 divided by T2. Put the value of T2, put the value of T1. So you will get the efficiency as a 14.7%. Are you getting that answer? COP of heat engine, or that is also called as the efficiency of heat engine. Okay. वरती फुल स्क्रीन करून बघता येते का पीपीटी? हॅलो, काय विचारतो की मोबाईल वरती फुल स्क्रीन करून बघता येते का पीपीटी? होय की नाही? ज्यांना बघता येत नसेल त्यांनी रोटेट मोड ऑन करा आणि मोबाईल आडवा पकडा. त्यानंतर तुमचा मोबाईल आडवा पकडल्यानंतर कंप्लीट स्क्रीन दिसेल तुम्हाला. So this is our first problem. Have you noted down this problem? Have you understood this problem? Okay. Shall I shift to the next slide? Next problem. Write down these three formulae and directly you can write down the answer. Not necessary to put that values. Directly you can write down that answer for your reference purposes. I will provide you 1 minute. Shall I shift to the next problem? May I shift to the next problem? Okay. Now next problem. We'll read the next problem. Thakre, you can read the problem. Why I am asking you to read the problem? Because whenever you are reading the problem, your attention will go on increasing. For that purpose only I am asking you to read the problem. Thakre.
Okay. A Carnot refrigeration cycle absorbs heat at 270 Kelvin and rejects it at 300 Kelvin. Calculate the COP of refrigeration cycle. If the cycle is absorbing 1130 kilojoule per minute at 270 Kelvin, how many kilojoule of work is required per second? If the Carnot heat pump operates between the same temperature as above refrigeration cycle, what will be its COP? How many kilojoule per minute will the heat pump deliver at 300 Kelvin if it absorbs 1130 kilojoule per minute at 270 Kelvin?
Okay. Now what you understood from this problem? So here 4 subparts are there. So first basic line is there is one Carnot refrigeration cycle which is absorbing heat. There is one Carnot refrigeration cycle which is absorbing heat at 270 Kelvin and the same refrigeration cycle is rejecting that heat at 300 Kelvin. So they have mentioned two temperature limit, 270 and 300 Kelvin. Out of that, heat absorption is taking place at 270 Kelvin, heat rejection is taking place at 300 Kelvin. So here we have to find out the value of COP of this refrigeration cycle. We have to find out the value of COP of this refrigeration cycle. So this is the first part. Second part, in the same cycle, in the same cycle, if heat absorption is taking place at 270 Kelvin and that amount of heat absorption is nothing but 1130 kilojoule per minute. If the cycle is absorbing 1130 kilojoule per minute at 270 Kelvin, then how many kilojoule of work is required per second? How many kilojoule of work is required per second? That means in the first sentence or in the first part, we have to find out the COP of refrigeration cycle. In the second part, they have provided the value of amount of QA. That is QA is equal to 1130. Then in that case, we have to find out the work done on the system. That is nothing but we have to find out the value of W. Then third part, if the same Carnot cycle is working as a, or if the same Carnot cycle is used for the heat pump, which operates between the same temperature limit as said above, refrigeration cycle, that is nothing but 270 Kelvin and 300 Kelvin. Then what will be its COP? That means third one, we have to find out the COP of heat pump, and fourth one, how many kilojoule per minute will be or will heat pump deliver at 300 Kelvin if it absorbs 1130 kilojoule per minute at 270 Kelvin. Are you able to solve this problem? Yes or no? Are you able to solve this problem? So I request all of you to close your notebook and please pay attention. So I will explain this problem. So next problem you have to solve. So close your notebook. Notebook is Lakshman Salgar.
Yes, sir.
Have you brought the notebook? Do you have the notebook? Yes or no?
Yes, sir.
Okay. So we'll solve this problem. Now, first of all, we'll write down the given data. So what is the given data? They have provided the value of, they have provided the two temperature. So first temperature is nothing but 270 Kelvin. Second one is nothing but 300 Kelvin. So out of that, lowest temperature will be considered as a T1, highest temperature will be considered as a T2. Then second thing, first of all, we have to calculate the COP of refrigeration cycle. So we are knowing the formula for calculation of COP of refrigeration cycle. What is the formula for calculation of COP of refrigeration cycle? So this is the simple one. So we are knowing the formula for calculation of COP of refrigeration cycle, that is nothing but T1 divided by T2 minus T1. So put the value of T1. What is the value of T1? Value of T1 is nothing but 270 Kelvin. Value of T2 is nothing but 300 Kelvin. So put those value, you will get the value of COP of refrigeration cycle as nothing but 9. Second thing, what we have to calculate, if the cycle is absorbing 1130 kilojoule per minute from 270 Kelvin. If the cycle is absorbing 1130 kilojoule per minute from 270 Kelvin, how many kilojoule of work is required per second? So for that purpose, we will draw one diagram. So we are knowing that there are two temperatures. First one is nothing but 270 Kelvin. Second one is nothing but 300 Kelvin. So in the refrigeration cycle, heat will be absorbed from the lower body temperature, that will be rejected to the higher body temperature. To do so, we require to provide the work. So here that refrigeration cycle is absorbing 1130 kilojoule per minute amount of heat from 270 Kelvin temperature body. So in that case, we have to find out how much amount or how many kilojoule amount of work will be supplied on the system. So for that purpose, now which formula we require to use? कोणता फॉर्म्युला यूज करणार आहे आता? पाठीमागच्या केसमध्ये पहिल्या सब पॉइंट मध्ये आपण काय कॅल्क्युलेट केलेले? सीओपी ऑफ रेफ्रिजरेशन सायकल फाइंड आउट केलेले. व्हॉट इज द व्हॅल्यू ऑफ सीओपी ऑफ रेफ्रिजरेशन सायकल? That value of COP is nothing but 9. So as we were knowing the value of T1 and T2, we were able to calculate the value of COP. Now in the second case, we have to find out the value of work supplied to the system, and for that purpose they have provided the value of amount of heat absorbed from the system. So as we are knowing the amount of heat absorbed from the system, so we are knowing the another formula for COP. So another formula for COP of refrigerating cycle is nothing but QA divided by QR minus QA. So here we will use the same formula, that is, as we are knowing that QA is nothing but Q1, that Q1 is nothing but 1130 kilojoule per minute. So as they have asked us find out the work supplied to the system in terms of kilojoule per second. So first of all, we will convert that QA from kilojoule per minute into kilojoule per second. So for conversion of QA from kilojoule per minute to kilojoule per second, we require to divide this value by 60. So here I will get the value of QA. So after getting the value of QA, I am knowing the formula of COP of refrigerator. So COP of refrigerator is given by equation Q1 divided by work done, or that is another way, Q1 divided by Q2 minus Q1, whereas Q2 minus Q1 is also called as the work done on the system. So in the problem, as they have asked us find out the work done on the system, so I am using the formula as a Q1 divided by work done. So what is the value of Q1? Value of Q1 is nothing but 18.83. I am knowing the value of COP of the refrigerating cycle. So what is the value of COP of refrigerating cycle? So in the first point we have calculated that value, that is nothing but 9. So put those values. So COP of refrigerating cycle is nothing but equal to 9. Q1 is nothing but 18.83. I will automatically get the value of work done. So that value of work done is nothing but equal to 2.1 kilojoule per second. इथपर्यंत समजतंय का सगळ्यांना? हॅलो, प्रत्येकाला समजतंय का?
Yes, sir.
समजतंय? Okay. So this is the answer of your second question. Now third question. What is the third question? We have to find out the if the Carnot heat pump operate between the same temperature as above refrigeration cycle, what will be its COP? म्हणजे instead of refrigeration cycle which is operating between the same temperature limit, if that refrigeration cycle or refrigerator will become as a heat pump, then what will be the COP of that heat pump? So what formula or which formula we have to use? As we are knowing the COP of refrigerator, we can use the COP of heat pump is nothing but COP of refrigerator plus 1. So here for third one, as we are knowing that COP of heat pump is nothing but equal to COP of refrigerator plus 1, or you can use another formula also, T2 divided by T2 minus T1. So as COP of heat pump, COP of refrigerator was 9. So 9 plus 1 is nothing but 10. So by both the way, you will get the same answer. So COP of heat pump is nothing but 10. So you can find out that this value by using the formula as the COP of heat pump is equal to COP of refrigerator plus 1, or by another way, that is nothing but COP of heat pump is equal to T2 divided by T2 minus T1. So COP of heat pump is nothing but 10. Now fourth one. What is the fourth one? Fourth one is nothing but how many kilojoule per minute will the heat pump deliver at 300 Kelvin if it absorbs 1130 kilojoule per minute at 270 Kelvin. म्हणजे ते काय म्हणतात आपल्याला, जर T1 पासून 1130 किलोजूल अमाऊंट ऑफ हीट जर ऍब्झॉर्ब केली असेल, तर T2 ला अमाऊंट ऑफ हीट T2 ला आपण किती अमाऊंट ऑफ हीट रिजेक्ट करणार आहे, जर ती मशीन ऍज अ हीट पंप वर्क होत असेल तर. ती मशीन काय होते, ऍज अ हीट पंप वर्क होते. दॅट heat pump is operating between the temperature range of 270 Kelvin and 300 Kelvin. On that heat pump, we are supplying the work. So they have asked us if 1130 kilojoule per minute amount of heat is being absorbed from a body whose temperature is 270 Kelvin, then how much amount of heat will be rejected? How much amount of heat will be rejected to the T2 temperature body? So as we are knowing the COP of heat pump, so what is the value of COP of heat pump? 10. So we can use the another formula to calculate the heat delivered by the heat pump at 300 Kelvin. We will use the formula as a COP of heat pump is nothing but Q2 divided by Q2 minus Q1. As we are knowing the formula for COP of heat pump, so COP of heat pump is nothing but Q2 divided by Q2 minus Q1. So we are knowing the value of Q1. So what is the value of Q1? Value of Q1 is nothing but 1130. Value of Q1 is nothing but 1130, and we are knowing the value of COP of heat pump. So value of COP of heat pump is nothing but 10. So put those values. So 10 is equal to Q2 divided by Q2 minus 1130. So here you will get the value of Q2, whereas Q2 is nothing but amount of heat rejected to the 300 Kelvin temperature body. Amount of heat rejected to the 300 Kelvin temperature body. Are you getting? Are you getting the problem or solution of problem? भगवान कोणते सांगा. So as first time on the slides we are solving the problem. Up till now whatever problem we are solving, those problems we are solving on the green board or white board, but first time in the history we are solving the problem on the PPTs. So whether it is understand whether you are able to understand by using these slides, there are some problem or there is some understanding problem. लगे समजतंय का? अक्षय नायकू, नायकू so shall I give the time for writing or noting down this PPT or this problem, or is it not necessary? What should we do? काय करायचं? ते बघा, कोणीतरी बोलल्याशिवाय मला समजणार नाही नक्की काय करायचं ते.
झाले लिहून सर.
लिहून झालेलं?
हा.
Okay. Now next problem. That problem will be for that problem you have to solve. So I will give the time, 5-minute time, and in that 5-minute time you have to solve this problem. So who will read the problem? Bhumkar, can you read the problem? Mansi Bhumkar. पंकज खंबीरे. Yogesh Raut, can you read the problem?
Yes, sir.
Read the problem.
1.5 kilowatt per ton of refrigeration is required to Maintain the temperature of minus 40 degrees Celsius in the refrigerator. If the refrigeration cycle works on Carnot cycle, determine the following: COP of cycle, second, temperature in sink, third, heat reject to sink per ton of refrigeration, and last, heat supplied and E- E- EPR if cycle is used on base pump, heat pump.
Used as a heat pump. 1.5 kilowatt per ton of refrigeration. 1.5 kilowatt per of refrigeration is required to maintain the temperature of minus 40 degree in a refrigerator. Ignition cycle works on the Carnot cycle. Then we have to find out COP of the cycle. Second one, we have to find out temperature of the sink. Third one, we have to find out heat rejected to the sink per ton of refrigeration. And fourth one, we have to find out heat supplied and EPR. EPR means energy performance ratio if cycle is used as a heat pump. If cycle is used as a heat pump. So take the 5 minutes and try to solve this problem. Take the 5 minutes and try to solve the problem. So whenever you will try to solve the problem, so either you will get the solution or either you will stuck up somewhere else. So whenever you will stuck up, so while solving the problem, you will get the concept clear or you will get the understanding of that concept. Is there anyone who is able to solve the problem? If not, then where you are stacking up. At least you can tell me that where you are stacking up. At least are you trying to solve the problem? Product. ऋषिकेश देशमाने. देशमाने.
Yes, sir.
पंकज खंबीरे. काहीतरी बोलत जावा.
Yes, sir.
सॉल्व करायला चालू केलंय का?
करतोय सर, ट्राय करतोय.
Okay. At least try to solve the problem. I'm not expecting the answer. So whenever you are trying to solve the problem, you will get you will stuck up somewhere somewhere. So while solving the problem, you'll get that concept clear. Are you able to solve the problem, or shall I explain? What should I do? What should we do? Are you able to solve? कैसे सांगा? तर म्हणा नाहीतर म्हणा. Okay. Shall I explain? Okay. Close your notebook and please pay attention. I will explain. All of you, please close your notebook and please pay attention. Have you closed your notebook? So here, first line is nothing but 1.5 kilowatt per ton of refrigeration. 1.5 kilowatt per ton of refrigeration. What is the meaning? So if you understand this first sentence itself, you will able to solve the problem. So 1.5 kilowatt per ton of refrigeration is required. That means whenever you are going to 1.5 kilowatt amount of work, whenever you are going to supply 1 kilowatt, because always kilowatt is the unit of work done on the system. So 1.5 kilowatt work is required to supply to obtain 1 ton of refrigeration. What is the meaning of 1 ton of refrigeration? That is nothing but if you want to absorb kilojoule per minute amount of heat, kilojoule per minute amount of heat, that means 1 ton of heat, then you require to supply the 1.5 kilowatt amount of work on the system. So then you are able to maintain minus 40 degrees centigrade in the refrigerator. That means your given data is nothing but there are two temperature body. First one is nothing but lower temperature or cold temperature called as a T1, whose temperature we want to maintain as a minus 40 degrees centigrade. So minus 40 means that will be 233 Kelvin. You have to maintain the temperature as a minus 40 degrees centigrade. That is nothing but 233 Kelvin. So that will be called as a cold body temperature. Another will be the hot body. So if this is a refrigeration cycle, then always you are absorbing the heat from the lower temperature body. That heat will be rejected to the higher temperature body. For doing so, you require to supply the work. Now, how much amount of work you require to supply? You require to supply 1.5 kilowatt amount of work. You require to supply 1.5 kilowatt amount of work. Then you are able to obtain ton of refrigeration. 1.5 kilowatt per ton of refrigeration is required to maintain. So here, whenever you are supplying 1.5 kilowatt amount of work, then you are able to absorb the heat equal to 1 TR. So 1 TR is nothing but 210 kilojoule per minute. 210 kilojoule per minute. So as you are getting the value of QA in terms of kilojoule per minute, so convert that work done or work supplied to the system in terms of kilojoule per minute. So 1.5 kilowatt means it is nothing but equal to 1.5 kilojoule per second. So which is nothing but equal to, if I want to convert it in terms of minute per minute, then I need to convert or I need to multiply this value by 60. So 1.5 into 60, that is nothing but 90 kilojoule per minute. आता तुम्हाला सॉल्व करता येईल. So here this three value you are knowing, that is nothing but T1 is equal to 233 Kelvin, Q1 is nothing but 210 kilojoule per minute, WR or work done on the system is nothing but 1.5 kilowatt, which is nothing but equal to 90 kilojoule per minute. इथपर्यंत समजलं का सगळ्यांना? इथपर्यंत समजलं का? Yes or no? इथपर्यंत समजलं असेल तर पुढचा प्रॉब्लेम सोपा आहे. इथपर्यंत समजलं, कारण की पहिलं सेंटेन्स काय दिलेलं आहे 1.5 किलोवॅट. आता किलोवॅट कशाचं युनिट आहे? वर्क डनचं युनिट आहे. म्हणजे आपण काय करतोय, सिस्टीमला वर्क डन देतोय. किती देतोय? 1.5 किलोवॅट. ज्यावेळेस आपण 1.5 किलोवॅट वर्क डन देईल त्यावेळेस काय होते, 1.5 किलोवॅट पर टन ऑफ रेफ्रिजरेशन. म्हणजे ज्यावेळेस मला 1 टन ऑफ रेफ्रिजरेशन हीट ऍब्झॉर्ब करायचे त्यावेळेस मला किती द्यावे लागणार आहे? वर्क 1.5 किलोवॅट. असं त्याचं मिनिंग आहे. नाउ हिअर I have to find out the COP of cycle. So how to calculate the COP of cycle? As I am knowing the value of QA, that is nothing but Q1. As I am knowing the value of work done, so I am able to calculate the value of COP. So here given data is nothing but WR is equal to 1.5 kilowatt, which is nothing but 90 kilojoule per minute. Q1 is nothing but 210 kilojoule per minute. T1 is nothing but 233 Kelvin. त्यापैकी पहिली व्हॅल्यू काय कॅल्क्युलेट करायचे? सीओपी कॅल्क्युलेट करायचे. सीओपी कोणत्या फॉर्म्युलाने कॅल्क्युलेट करणार आहे मी या ठिकाणी? कोण सांगेल? बाय विच फॉर्म्युला आय हॅव टू कॅल्क्युलेट द व्हॅल्यू ऑफ सीओपी?
QA upon W.
ओके, QA दॅट इज नथिंग बट Q1 डिवाइडेड बाय WR. Q1 ची व्हॅल्यू माहिती आहे मला 210, WR ची व्हॅल्यू माहिती आहे, किंवा वर्क डन ची व्हॅल्यू माहिती आहे 90. So Q1 upon WR, that is nothing but COP of cycle. Then second one, what I have to calculate? Temperature of sink. Temperature of sink. So in thermodynamics, we are knowing the two concepts. First one is called as a source. Second one is called as a sink. First one is called as a source. Second one is called as a sink. So source is nothing but, source म्हणजे काय असतो? ज्याच्याकडून आपण सप्लाय करतो, आणि सिंक म्हणजे ज्याला आपण रिजेक्ट करतो किंवा ज्याला आपण देतो. त्या ठिकाणी आपल्या हीट इंजिन मध्ये सोर्स म्हणजे काय असतं? हायर टेम्परेचर बॉडीला आपण काय म्हणत असतो? आपण सोर्स म्हणत असतो, आणि लोअर टेम्परेचर बॉडीला सिंक म्हणत असतो. रेफ्रिजरेटर रिव्हर्स ऑफ हीट इंजिन. त्यासाठी आपण काय करणार आहे या ठिकाणी? रेफ्रिजरेटर मध्ये सोर्स काय असला पाहिजे आपला? लोअर टेम्परेचर बॉडी कडून आपण ऑलवेज हीट ऍब्झॉर्ब करत असतो. त्यामुळे त्या ठिकाणी सोर्स काय असतो? लोअर टेम्परेचर बॉडीला सोर्स म्हणतात, आणि हायर टेम्परेचरला म्हणजे ज्याला आपण हीट रिजेक्ट करणार आहे त्याला मी काय म्हणणार आहे? सिंक म्हणणार आहे. सो हिअर सेकंड वन, आय हॅव टू फाइंड आउट द टेम्परेचर ऑफ सिंक. सो दॅट मीन्स आय हॅव टू फाइंड आउट द व्हॅल्यू ऑफ T2. T2 ची व्हॅल्यू कशी कॅल्क्युलेट करेल? T2 ची व्हॅल्यू कशी कॅल्क्युलेट करायची? कोण सांगेल? हाऊ टू कॅल्क्युलेट द व्हॅल्यू ऑफ T2? COP मिळालाय तुम्हाला? व्हॉट इज द व्हॅल्यू ऑफ COP? 2.33 आलाय का?
Yes sir.
हा, COP मिळालेलं आहे. T1 माहिती आहे तुम्हाला?
Yes sir.
T2 कसा कॅल्क्युलेट कराल मग?
COP is equal to T1 divided by T2 minus T1.
ओके, COP इज इक्वल टू T1 डिवाइडेड बाय T2 मायनस T1. त्यापैकी COP ची व्हॅल्यू माहिती आहे, T1 ची व्हॅल्यू माहिती आहे, T2 ची व्हॅल्यू तुम्हाला ऑटोमॅटिक कॅल्क्युलेट करता येईल. समजते? त्यानंतर थर्ड वन काय कॅल्क्युलेट करायचं आहे? कॅल्क्युलेट दी हीट रिजेक्टेड टू दी सिंक पर टन ऑफ रेफ्रिजरेशन. हीट रिजेक्टेड टू दी सिंक पर टन ऑफ रेफ्रिजरेशन. त्याचा अर्थ काय होतोय? ज्यावेळेस तुम्ही Q1 1 TR असेल त्यावेळेस Q2 ची व्हॅल्यू किती असेल? Q1 ज्यावेळेस 1 TR असेल त्यावेळेस Q2 ची व्हॅल्यू किती असेल? कशी कॅल्क्युलेट करणार आहे Q2 ची व्हॅल्यू? कोण सांगेल? Q2 ची व्हॅल्यू कशी कॅल्क्युलेट करतो आपण? या ठिकाणी
Q1 plus
Q2 म्हणजे काय
W.
असतो? ओके, Q2 म्हणजे काय असतो? Q1 प्लस WR असतो. आपण बघितलेलं आहे पाठीमागं. Q2 इज नथिंग बट Q1 प्लस WR. Q1 ची व्हॅल्यू किती आहे? 210 आहे. WR ची व्हॅल्यू किती आहे? 90. दोन्ही सेम युनिट मध्ये घ्या, किलोजूल पर मिनिट, किलोजूल पर मिनिट. सो 210 प्लस 990 that is nothing but 300 kilojoule per minute. That is nothing but the answer of your third question. That is nothing but heat rejected to the sink per ton of refrigeration. And what is the fourth one? Heat supplied and EPR if cycle is used as a heat pump. म्हणजे हा जर रेफ्रिजरेटर ऍज अ हीट पंप यूज केला तर त्या ठिकाणी अमाऊंट ऑफ हीट सप्लाय किती असेल? हीट सप्लाय म्हणजेच काय झाली? हीट सप्लाय कशाला करतो? आपल्याला कशाला करत असतो आपण हीट पंप मध्ये? ज्या रूमचं आपल्याला टेम्परेचर सराउंडिंग टेम्परेचर पेक्षा जास्त मेंटेन करायचं असतं त्या रूमला आपण काय करत असतो? नेहमी हीट सप्लाय करत असतो. हीट सप्लाय म्हणजेच काय असणार आहे? हीट रिजेक्टेड असणार आहे. म्हणजे ते काय विचारतात? Q2 ची व्हॅल्यू विचारतात. Q2 ची व्हॅल्यू आपण ऑलरेडी कॅल्क्युलेट केलेली. किती आलेले? 300 किलोजूल पर मिनिट. आणि दुसरं काय विचारलेलं आहे? EPR म्हणजे एनर्जी परफॉर्मन्स रेशो. दॅट इज ऑल्सो कॉल्ड एज अ COP of heat pump. So EPR if cycle is used as a heat pump. तर COP काय येणार आहे ह्याचा? किंवा EPR काय येणार आहे?
3.33.
किती येणार आहे? जर COP ऑफ हीट रेफ्रिजरेटर 2.33 असेल तर COP ऑफ हीट पंप
3.33.
किती असणार आहे? 3.33. So this is the solution of this problem. So are you getting the solution of problem? Yes or no? So first one, we will calculate the COP of refrigerator as you are knowing the value of QA or Q1 and WR. So Q1 divided by WR is nothing but COP of refrigerator whose value is nothing but 2.33. Then we will calculate the temperature of sink. Temperature of sink is nothing but T2. So as I am knowing the value of COP of refrigerator, so I will use the formula as a COP of refrigerator is equal to T1 divided by T2 minus T1. So put the value of T1, put the value of T2, I will get the COP of refrigerator. Sorry, not COP. I will get the value of T2. So value of T2 we are getting as a 333 Kelvin. Then third one, we have to calculate heat rejected to the sink per ton of refrigeration. That means we have to find out the value of Q2. So to calculate the value of Q2, we are knowing the formula, that is Q2 is equal to Q1 plus WR. So what is the value of Q1? 210. What is the value of WR? 90. So Q2 is nothing but 300 kilojoule per minute. And last thing, we have to calculate heat supplied and energy performance ratio if cycle is used as a heat pump. So out of that, heat supplied already we have calculated, that is nothing but 300 kilojoule per minute in the above equation. This value already we have calculated. And second one, energy performance ratio means COP of heat pump. So that will be equal to COP of refrigerator plus 1, and that value will be equal to 3.33. समजला प्रॉब्लेम? होय की नाही? You got the problem?
Yes,
Shall we
sir.
solve one more problem? Shall we solve one more problem? What is the time now?
नको सर, टाइम झाला
Whether
आता.
whether these many problems are sufficient?
Yes, sir.
Okay. Shall we stop our lecture?
Yes, sir. Yes, sir.
Wait, let me take the attendance. So, are you able to understand the problem? Yes or no?
Yes, sir.
So, I took the attendance. So, thank you for attending the lecture. So, whatever next part will be there, we'll continue that next part in the next lecture. Thank you. Now you can exit the meeting.